Okay, in this video, we're going to start talking about another conic section called the parabola, and we've discussed parabolas in the past already. A parabola is the locus of points such that each point on that parabola is the same distance from a fixed point called the focus, which is right here, and a line called the directrix. Now, when we say distance to a line, make sure that distance must be a perpendicular distance. So we're going straight down to that line. So this distance and this distance is the same. So D1 would equal to D2 for all points on that parabola. And that's going to become important to us in just a second when we talk about some parts of this parabola. So types of parabolas, we have a vertical parabola that opens up and down. That's the ones we're used to seeing. But you also have a horizontal parabola that opens up to the left or to the right. The blank always lies inside of the parabola, and that would be the focus. And we can see the focus right here, and we see the focus of this parabola right here. It always curves around that, around those foci, as with any of these conic sections. Conic sections always curve around the foci or the focus. The blank always lies outside of the parabola. That would be your directrix. The directrix is the line that the points are equidistant from. So this point is equidistant from the focus and from this directrix. Here's your directrix right here. This line would be the directrix. The blank and blank are perpendicular. That would be your directrix, which we just discussed, and the axis of symmetry. And we've done axis of symmetry before, the whole x equals negative b over 2a. This line right here that cuts it symmetrically. So your directrix and your axis of symmetry will always be perpendicular to each other. The vertex is going to be p units away from the focus and directrix. And I'm going to put plus and minus because the distance from here to here, that's going to be up p, and this would be down p. So since the vertex right here, let me show you. Since the vertex is p units away from this, well, it's a point on that parabola, so it would have to be the same distance because that point has to be the same distance from the focus as it is from the directrix. The blank is a segment that passes through the blank with endpoints on the parabolic curve and has a length of. The lattice rectum. The lattice rectum is a segment that passes through the focus. And let's talk about the length of it. The lattice rectum is actually parallel to the directrix. Let's kind of draw it right here. This is the lattice rectum. Okay, now let's talk about the length of this. Well, the lattice rectum intersects the parabola here and here, passes through the focus. Let's talk about this distance here. Well, the distance from here to here would be the same as from here to here, so that'd be p. The distance from here to here would be the same as this, which is also p. So the distance from here to here would be 2p. Since this point is on the parabola, it is the same distance from the directrix as it is from the focus, so this would be also a distance of 2p. Since this thing is symmetrical, this over here would also be a distance of 2p, so the lattice rectum will always have a length of 4p units. And that would be the same for here. If I were to draw this line right here that passes through the focus, this lattice rectum has a length of 4p units. Now, I went ahead and put the formulas here. These are a little bit different than you're going to see in some books and on some websites. If it is a vertical parabola, if it opens up and down, your equation is y equals 1 over 4p, and we've already discussed what that p is. That's the distance to your focus and the distance to your directrix. X minus h is going to move your parabola left or right backwards like it always does. It's in parentheses with that x. Now k, however, is going to move it up or down exactly what it says. If it's plus 2, it moves it up 2. If it's minus 2, it moves it down 2. So it opens up if p is greater than 0. It opens down if p is less than 0. Now this whole 1 over 4p, we're used to seeing that as our a value. Y equals a times x minus h. We dealt with that in transformation form. It's the same thing as our a. So what makes our a value negative? What makes it cut down? Well, if p right here is negative, then the whole thing would be negative, and that's why. So in our second form, we're going to open up to the right. Again, if p is positive, it's going to open up like this. However, if P is negative or less than 0, then our parabola would open to the left. So there's the two basic forms. So now let's sketch some of these. Write the equation in standard form, like we just saw. Determine the type of parabola, whether it's up and down, left and right. We're going to graph the vertex. We're going to solve for P and to determine the direction of the opening, whether it's up or whether it's down, left or right. Use the absolute value of P to graph the focus and directrix. Use the absolute value of 4P to graph the endpoints of the lattice rectum, and then let's sketch the parabola. Okay, so let's work some problems. It says graph the parabola, identify the vertex, focus, endpoints of the lattice rectum, the axis of symmetry, and the directrix. Well, let's first off get it in the form, our standard form, and here's how we're going to do it. Since 2 is being multiplied, the first thing I would do is move it to the other side by dividing. Dividing by 2 and multiplying by 1/2 is the same thing. So let's come out here in front of this whole term, and let's multiply it by 1/2. And you now have equals y plus 3. And the last thing we got to do now is move the plus 3 over by subtracting 3, and you now have 1/2 x minus 4 squared minus 3. And instead of putting equals y, I'm going to put the y out front, and there is your equation. So let's look at our transformation on our vertex. This would move your vertex right 4 because it's inside parentheses with an x. It moves it backwards what you think it would. This would move your parabola down 3. So right 4 down 3 has a vertex now at right 4 down 3 or 4 negative 3. Let's go ahead and plot that vertex. Now next up, I like to find the focus and directrix. And the way we're going to find that, well, we could actually find the axis of symmetry first because that's fairly easy. The axis of symmetry, since this is a vertical parabola, and how do I know it's vertical? Because it's x squared stuff. Anytime it's x squared, it's vertical. If it's y squared, it's going to be horizontal. So the axis of symmetry will be the line, and I'm going to draw a dotted line. The dotted line here that cuts it into two perfectly equal sides. It's always going to be, if it's a vertical line, that's going to be an x equals line. And it's always going to pass through the vertex, so it's going to be a value of x equals 4. So there's your axis of symmetry. Now let's find the p-value so we can find our focus and directrix. The way you find the p-value, this number out front is equal to 1 over 4p from our formula. And you can see that up here. Let me scroll back up. There's your 1 over 4p out front. So we're going to set 1 over 4p in this parabola equal to 1/2. Get rid of the fractions by multiplying. Divided by 2, go to the other side and multiply by 2. Divided by 4p, go to the other side and multiply by 4p. So you have 4p is 2. You're the 4 divide, so therefore you get p has a value of 1/2. Since it is positive, that means your parabola is going to open up. Okay, if it was negative, that means it would cup down. So from our vertex, we're going to go up half a box, and there is your focus. So instead of at -4, 3, go up a half a box, or excuse me, 4 negative 3, go up a half a box, and your focus is going to be now at 4. It's going to be the same as the vertex, and then -2.5. Your directrix is going to be lower. It's going to be the exact same distance on the other side. So therefore, since this is 4 negative 3, your directrix, which is a horizontal line, is going to be located at -3.5. So there's your focus, your directrix, your axis of symmetry. And the last thing is going to be our lattice rectum. Your lattice rectum is going to have a length of 4 times p. Since our p-value was 0.5, 4 times 0.5 has a length of 2. And that distance goes through, again, your focus. So on each side of the focus, you're going to have half of that. So 1 to this side, 1 to this side, and there's what your parabola is going to look like. Now, you can find other points on that, but since it just says sketch a graph, let's go ahead and just connect our dots, connect your vertex with the endpoints of that lattice rectum, and there's what you're going to have. Now, the lattice rectum has a length of 2, but this actually says find the endpoint. So what you're going to have to do from your focus, you're going to have to go, since the whole distance is 2, go 1 to the right and 1 to the left. So your endpoints are going to be located at 5, -2.5, and at 3, -2.5, which is 1 to the left and 1 to the right. Okay, let's move on to the next one. Number 2, notice that x is not being squared, but the y is. So that means that this is going to be a horizontal parabola, which means it's going to either open up left or right. So let's move the 8 over by taking 1/8 of the other side. So you have x is equal to 1/8 y plus 2 squared. So our vertex first off, now this is kind of tricky. There's a +0 out here that does exactly what it says it's going to do. However, since this is an x equals parabola, this value is going to move it left or right. And it's going to move it left or right 0. Now inside with the y, +2, now things happens backwards for the y. Since it's a +2, it's going to move it down 2. So we have a vertex at 0, -2, which is right there. Now let's go ahead and find our axis of symmetry. Our axis of symmetry, since this is a horizontal parabola, your axis of symmetry is going to be a horizontal line. There we go. So it's going to be a y equals line, and it's going to be y equals -2 because, again, it passes through the vertex. Now let's find our focus and directrix by finding our p-value. Set the number out front equal to 1 over 4p. So 1 over 4p equals 1 over 8. And you can very easily look at 4p and 8, and you can tell that p is going to equal 2. So therefore, in order to find our focus and our directrix, our p-value is positive. So that means it's going to open to the right. Let's find our focus first. Let's go to the right 2 units. There's going to be the focus. Go left 2 units, and there's going to be the directrix. So let's go ahead and identify our focus and our directrix. Our focus is located 2 units to the right of our vertex, so it is located at 2, -2. Our directrix is a vertical line, so it's going to be x equals -2 will be our directrix. The last thing we're going to do is find the endpoints of the lattice rectum. The lattice rectum is going to have a length of 4p, so that's going to be 4 times 2. It's going to have a length of 8. So therefore, from our focus, we're going to be, the whole length is 8, so we're going to go 4 on one side, and we're going to go 1, 2, 3, 4 on the other side, and that's going to be 2 points on our parabola. And that just goes to show us that our parabola is going to be really wide in this case. The bigger that p-value is, the wider that this parabola is. So an extremely wide parabola. So these endpoints of the lattice rectum are going to be located up and down from that focus. So let's take our focus, which was at 2, -2, and let's go up 4 to 6, -2. Or actually, let's try that again. Up 4 to 2, 2, and down 4 to 2, -6. So there's 2, 2, there's 2, -6. That's the endpoints of the lattice rectum. Okay, number 3, let's go ahead and move our -16 over by dividing by -16, which again is the same thing as multiplying by the reciprocal. -1/16 y minus 1 squared equals x minus 5. Now let's isolate our x by moving the 5 over. So we now have -1/16 y minus 1 squared plus 5. And instead of putting equals x, I'm going to put the x out front. So now we are in standard form. Now let's talk about our vertex. Again, since it's x equals, this plus 5 is going to do exactly what it says it's going to do. It's going to move it right or left. And since it's a plus 5, it's going to move it right 5. So my vertex is now located at 5, comma. The -1 on the y is going to do backwards what it says. Since it's a -1, it's going to move it up 1. So my vertex is going to be located at 1, 2, 3, 4, 5, 1 right here. Let's go ahead and find our axis of symmetry. Since it's an x equals, we're going to have a horizontal axis of symmetry. So here is my axis of symmetry at y equals 1. Next up, let me go ahead and darken my vertex right there. Next up, let's go ahead and find the value of p. Now, I do want to point out that since this -1/16, since it is a negative, that my parabola is going to cut to the left. So it's going to bend around the focus. So the focus is going to be to the left of the vertex here. So let's set 1/4p equal to -1/16. Get rid of 4p and 16 by multiplying, and that gives me 16 equals -4p. And again, you see that p has a negative value, which is again why your focus is to the left of the vertex. So let's go ahead and plot that. So let's go 1, 2, 3, 4 to the left, and we can go 1, 2, 3, 4 to the right, and we can draw our directrix. So my focus is located at 1, 1, and my directrix is a horizontal or a vertical line at x equals 9. Last thing, let's go ahead and find the lattice rectum. And again, you can just plug in values and get other points on this parabola. But let's go ahead. The length of the lattice rectum is going to be 4p. Since the value of p was -4, and again, we're only worried about the absolute value because we're talking distance, the length of the lattice rectum is going to be 16. So what I'm going to do, I'm going to find my focus, and I'm going to go 8 on each side. I'm going to go 8 to one side, and I'm going to go 8 to the other side. I believe it's located right there. And those endpoints are going to be located at 1, 9 and 1, -7. Now all I've got left to do is connect my dots, and my parabola is going to look something like this. Okay, the next one, number 4. Again, all we got to do here to get this in standard form is to move my 4 over. So we now have -1/4 x minus 2 squared plus 4 is equal to y. My vertex, now this is a y equals, so this is going to be a vertical parabola. Yes, vertical parabola. Since it's a negative, that means it's going to cup down. So my parabola is going to look something like this. So let's find our vertex first. The -2 on the x is going to move it to the right 2, backwards from what you think, and the +4 is going to move it up 4. So my vertex is going to be located at 2, 4, which is right there. Next up, let's find our axis of symmetry. Since it is a vertical parabola, my axis of symmetry does pass through the vertex here. So that's going to be an axis of symmetry of x equals 2. Next, let's find the value of p so that we can find the focus and directrix. Set 1/4p equal to -1/4, and you can already see that p is going to be -1. And again, that is the reason it's cupped down instead of cupped up. So let's go down 1, and there would be my focus. Let's go up 1, and that's going to be my directrix. So we have a focus at 2, 3. And we have a directrix, again, it's a horizontal line at y equals 5. Finally, since we have a p-value of 1, let's find the endpoints for a lattice rectum. A p-value of 1 means that the lattice rectum will have a length of 4. So what we can do is go 2 on each side of our focus, and that's going to be where the endpoints of that lattice rectum lies. And again, just a reminder why every point on my parabola is the same distance from the focus as it is from the directrix. If you look from here to here, that's a distance of 2. From here down to here is also a distance of 2, so therefore we know that point's going to be on the parabola, as well as this point. So therefore there's the endpoints of the lattice rectum, and my parabola will look something like this. And again, we can plug in x and y values to find other points on that parabola. But the endpoints of that lattice rectum is going to be located 2 to the left and 2 to the right of my focus. So that's going to be at 0, 3 and at 4, 3. Okay, number 5. Again, to get x by itself, all we have to do is move the 3 over. So we have x equals 1/10 y plus 2 squared plus 3. Since this is an x equals, that means that it's going to be a horizontal parabola. Since the value here of 1/10 is positive, that means it's going to cup to the right. First step, let's find our vertex. The +3 does exactly what it says it's going to do for the x values, because this is an x equals. It's going to move it right 3, and this +2 on the y is going to go backwards and move it down 2. So right 3 and down 2 gives me a vertex at 3, -2. So there's the vertex of your parabola. Next up, since this is a horizontal parabola, your axis of symmetry will pass horizontally through that vertex, and we'll have an equation of y equals -2. Next up, let's find the value of p so we can find our focus and directrix. In order to find that value of p, set this equal to 1 over 4p. Multiply, divide, solve the equation, and you're going to get p is equal to 2.5. And again, the way that I do that, I normally, if there's ones on top here and here, I just look at the bottoms and I say, what does p have to be in order to get a value of 10 on the other side? And that would be 2.5. So therefore, the distance to my focus and to my directrix is going to be 2.5. Since it cups again to the right, I'm going to go for my focus 1, 2.5 to the right. For my directrix, I'm going to go 1, 2.5 to the left. And there is going to be my vertical line for my directrix. So therefore, that focus is going to be located, again, 2 units to the right of my vertex. So that's going to be at 5.5, -2. My directrix is going to be located 2 units or 2.5 units to the left, and that's going to be at x equals 0.5. And again, it's a vertical line. That's the reason it looks like that. Since my p-value is 2.5, the length of my lattice rectum is going to be 4 times that. So my lattice rectum will have a length of 10. So I'm going to take from my focus, and I'm going to go 5 on each side. 1, 2, 3, 4, 5, which is about right there, and 1, 2, 3, 4, 5, which is right there, and that's going to be the endpoints of my lattice rectum. So I'm going to, from my focus, right here, I'm going to go up 5, and I'm going to go down 5. So the endpoints will be located at 5.53 and 5.5, -7. Connect my dots, and here is my parabola. Okay, in the next part, we're rewriting equations in standard form. And again, remember that I told you the standard form that I gave you might be slightly different from the standard form that they want. I would rather you write it in my form. So make sure that even though your answers might not match up with theirs, it is still correct. So we're going to rewrite the equation in standard form. Then we're going to determine if the direction of the parabola opening is up, down, left, or right. So first off, again, if it's a y-squared equation like this one, I want to solve it for x. If it's an x-squared, we're going to solve it for y. So let's go ahead and get our x by itself. Let's move our y-squared and 24 over. So that gives me 12x is equal to -y-squared and a -24. Then the last thing we're going to do is get rid of this 12 by dividing. I have a 1 right here. I'm going to divide by 12. And I have a 24. I'm going to divide by 12. Divide both pieces by 12. That gives you x is equal to -1/12 y-squared minus 2. So there's your standard form. Since it's an x equals, that means it opens either left or right. It's a horizontal parabola. Since this is a negative, that means it's going to open to the left. The next one is an x-squared equation. However, I have an x-squared and a 10x. So therefore, the first thing I'm going to do is I'm going to move my 6y over. And I now have x-squared minus 10x equals 6y minus 31. Now, since this does have an x-squared and a 10x, what we're going to do to make it look like the parabolas we've been dealing with is we're going to complete the square. There's no number out front, so it doesn't have to be factored out. So to complete this squared, we're going to take half of this squared, and we're going to add 25 to both sides. We're now going to factor, and that gives you a binomial x minus 5 to the second power equals 6y, -31, and positive 25 is -6. Now it's pretty easy. Move your constant term back over. That gives you x minus 5 to the second power plus 6 is equal to 6y. Now to get rid of this 6, we've got to divide both of these terms by 6. There is a 1 out front, and that's what I'm going to divide by 6 just to make it look better. I'm going to write that as 1/6, or you can think of it as to divide by 6. That's the same thing as flipping and multiplying, and I've also got to divide this by 6. So my y is equal to 1/6 x minus 5 squared plus 1. Since the x stuff is what's being squared, that means my parabola is either up or down. If this out front is a positive, that means my parabola opens up. So therefore, there's my standard form, and it does open up. Number 8, again, you have x squared stuff, and you also have 2x. So let's move everything to the other side. X squared plus 2x is equal to negative 20y and a negative 61. If there was a number in front of x squared, it would have to be factored out, but there's not, so we can go ahead and complete the square. Half it, square it, we're going to add 1 to both sides. So let's go ahead and factor it now. This is going to factor into x plus 1 times itself is equal to negative 20y and a negative 60. Let's go ahead and move that minus 60 back over, and I have now x plus 1 squared plus 60 is equal to negative 20y. Now I'm going to divide both of these terms by the negative 20. To divide the first term by negative 20, I'm just going to flip and multiply by negative 1 over 20. That's what we're used to seeing. Divide the second term by negative 20, I'm going to go ahead and write divided by negative 20. So I now have y equals negative 1/20th, x plus 1 squared, and then a positive divided by negative gives me a minus 3. So there's my standard form. Since it's y equals, that means it cups up or down. Since the number out front of my x squared stuff is a negative, that means it cups down. And the last one. I can already say, since there's a y squared there, that it's going to open up either left or right. I do have a y squared and y stuff, so let's go ahead and isolate those. Y squared minus 14y. Move all your x stuff to the other side. You got the x, and you have the constant on the other side now. Let's go ahead and complete the square. Half it, multiply it by itself. You're going to add a 49 to both sides. Now when you factor, that gives you y minus 7 times itself is equal to 2x, negative 45, and 49 gives me a positive 4. Now it's just moving everything back over. To get rid of the plus 4, we're going to subtract 4. We now have y minus 7 squared minus 4 is equal to 2x. To get rid of the 2, we're going to divide both of these terms by 2. To divide the first one by 2, I'm just going to flip and multiply. To divide the second one by 2, I'm going to write divided by 2. And I now have x equals 1/2 y minus 7 squared minus 2. Again, you see an x equals equation, so that means it opens either left or right. Since the number out front is positive, that means it's going to open to the right. And that's it.